Hi, my name's John. Welcome to another Sunday night nightcap. I actually feel a lot better myself. I'm nowhere near as depressed as I have been. I put this down to possibly different meds, but also the way people have been helping us. I've had emails, people have rang us up. Just something simple like one of the lasses at work gives a big cuddle. It makes a massive difference. So if you know somebody that's feeling like shit, really down, do your best to try and help them. It takes nothing to put a kind word in. And don't forget, if you are depressed, there is help available. Doctors, you know, you've got to talk about it, you've got to get it sorted out. Right, so fortunately for me, things are definitely looking up. I'm not 100%, but I'm a lot better than I was. I've spent a bit of time in a workshop. I had a friend come down from Alston, a lad called Aubrey. He gives a hand to build a gate and a fence in the garden to try and hide me metalworking exploits from Deborah. That was a good day. I really enjoyed that. I've done some work in the workshop. The video I'm going to show tonight is a two-part one. It's some Whitworth screw cutting. I find that if I concentrate on something really hard, and when you're screw cutting, you've got to concentrate all the time, especially on the manual lathe. It helps take your mind off things, helps clear your mind. Anyway, that's enough talk. Let's get on, get a nice video done. I've got a nice little straightforward engineering job to do here. I've got a piece of braid bar, and what the lad wants is 2 inches of thread put on the end, and that's the thread he wants. It looks to me like 1/2 inch Whitworth, more or less guarantee it's 1/2 inch Whitworth. Whitworth is 12 TPI, and that's bang on 12 TPI. If we measure it, just under 1/2 inch. This is a really old nut and bolt. It's an old type of nut. During the war they made the nuts a lot smaller to save on material. To me that is actually a pretty nut and a pretty bolt. They look nice, they feel nice. Real bit of quality. The modern equivalent to 1/2 inch Whitworth is 12 by 175, and you can see the amount of metal that they've actually saved. But to me that's an ugly nut and that's a pretty nut. I suppose that's just me. A few weeks ago I made the 63 tooth gear wheel. That's the one I made a mistake on, and I chipped the last tooth. Now I did make another one for the lad, and I've kept this one for myself, so it'll give us a chance to put this in the lathe, see if it runs quieter than the steel one, and also we'll need this in to do the screw cutting on that. I'll show you how the change wheels go together, how it works. I'll show you the table I've got. Spend a little bit of time screw cutting. Screw cutting's quite a therapeutic thing to do, and I feel a bit like shite at the minute, so I'm going to do some screw cutting and see if that'll cheer us up. Once again, it must be just me, but it's just a pretty nut and bolt. And that one there is pretty ugly. It'll be stronger, I know it will, but you can't whack the old English stuff. So I'll measure the OD, I'll measure the core diameter, and then we'll go about making the threads. But I think the first thing I'll do is go around the back of the lathe, put the change wheels on, go from there. This is a conversion chart for the Harrison lathe. It shows the gears I need to cut imperial threads between 8 and 60, where after that one now, which is 12. So what we need is a 50 tooth gear on the main shaft, which drives a 63, which is connected to a 40, which drives a 120. The 50 and the 120s are standard gears. That's the 63 I'm going to use, and that's the 40 I'm going to use. Those are the gears we've made. That's the conversion factor to go from metric to imperial. It's not 100% accurate, but it really is absolutely near enough for the sort of work I'm doing. This chart here shows the position of the various levers to cut the 12. That's 12 there. So we've got the 2 on the left, and we've got a right hand lever, which is only, I think only the Harrison 140s have that lever on, which means you can cut a lot more threads. And it just shows you where you put the levers to cut the 12 TPI. Looking in the back of the lathe, that's the lathe main shaft, that goes straight through onto the chuck. There's 2 little gears up in here called tumbler reverse gears, which engage this gear train. I do it that way, it's going forward. I do it that way, it's going backward. So that reverses direction of the feed for left or right hand threads. Next we've got a series of gears. This is a conventional gear setup. It's going from that one to that one to that one. You'll see when I put the compound gears on how these two gears are a pair of gears that change the ratio from metric to imperial. That there is the gearbox input shaft that goes into the gearbox, which feeds onto the lead screw. So we'll take the gears off, put the transfer gears on, and then see about doing some screw cutting. You can see it's nice and sticky and oily in here. They're straight cut gears. They're normally noisy in operation. The 63 tooth are made out of steel. It's particularly noisy, so I'm looking forward to trying the 63 tooth failure gear. I'll get some spanners and we'll start stripping this down. And put the lathe into gear so it locks it up. And keep the nuts in the same place on each particular thread. Right, so I've got all the gears stripped off, just the bare bones now. This part here is what they call a banjo. It's pretty obvious why they call it a banjo. That's adjustable and they're adjustable to get the mesh of the gears right. So according to our chart, we need a 50 tooth on the lathe main shaft, which is that one. 50 tooth, straightforward enough. The 50 tooth drives a 63, which is that one. So we need the 63 tooth gear putting on. Has a chance to be tight on the spring because it's not actually been used before. It is tight, but it's not be stupid tight. And on top of that one, we need a 40, which is also the gear that we've made. It is tighter than I would have liked that, but I'm sure it'll slacken off with use. Right, so that tightens, slacks through the record. Then 40 goes on. I've been going to make a space off of this for years and I haven't done it yet. That'll do. Okay, so we just said so that gear drives that one, then that gear drives a 120 down here on the gearbox input shaft. Loosen these off, you can see how the banjo moves up and down out the road. I'll put it down there so it's out everybody's way. We'll take that right up there like that. Right, so on here we need a 120, which has got to mesh with that one. So we'll need a spacer. Spacer goes on like that. And the 120 gear goes onto that. As so. Right, so that gear there meshes with that one. So we'll set that one up first. Bring that down to touches. You need a little bit of slack on these gears. You don't want them too tight. Some people put a bit of paper in between them. I'll just kind of feel it. Backlash there. That's a little bit tight. So there's that. That's good there. There's backlash in it, but not too much. Right, then we need to mesh this one with that one. Need to loosen off our banjo, lift it up till it meshes with that one. Once again, you don't need a colossal contact area, it hasn't got to be too tight. A little bit of backlash. Basically that's it. The gear train is noisy, it's as simple as that. That's straight cut gears. It can't be anything else really. A little damage tooth on that one, a sharp wear in. Tighten everything up. Not stupid tight, but just put enough on them. You can hear they're noisy. I'll put some lubricant on, put it back together. Just quite heavyish oil. I sometimes use chain spray on these. It's messy, but it does the job. There's a grease nipple on there, which is quite important. It's not a grease nipple, it's an oil nipple. We'll give that a squirt of just sladery oil. And that's basically now ready to work. So we've gone 50, 63, 40, that's the conversion gear, run to 120.